Hello guys and welcome to our new video. In this video, we will be covering the topics of week 5 and myself, Dhruv Janakala, your maths mentor. This is the page distribution page. You can use it while accessing the PDF. Next, for starting, let's go through the quote of the week. The greatest shortcoming of the human race is our inability to understand the exponential function. Everything in our life goes linearly, but some factors can make us exponentially grow. That's what it means by Sir Albert Alan Bartlett. So now we'll discuss what all things we are going to discuss in this lecture. First, we will go through some basic functions which you should know, which are covered in previous 4 weeks. Then we will go through exponential function. Then we will go through natural exponential function and also the concept of E. Then composite functions and then inverse functions. Week 5 and 6 are somewhat related, so it's better if you can go serially from now on. To begin with, what are basic functions? There are 3 basic functions that you should be known. First is the increasing function, second decreasing function, and third is the one-to-one function, where single input marks to single output. In increasing function, the domain A and R, where you can say both of them are belongs to real numbers, such that x1 and x2 are 2 inputs, let's say, which belongs to the domain A. And when these two, for we can set some condition on this, let's say x1 is less than x2. So when it's an increasing function, then the function's value after substituting should also follow this rule, that if x1 is less than x2, then function of f1 should be less than f2. And then we can say that the function is an increasing function. Same for decreasing function. Let's say there is domain is to codomain where A and B both belong to real numbers. X1, x2 are 2 elements which belongs to the domain. In this case also we will take that x1 is less than x2. But as we know that it's a decreasing function, therefore the value of x1 when substituted should be greater than that the value of function at the point of x2. The reason is because when this case is fulfilled, then the function is decreasing function. I will show you the graphs also ahead. Then in one-to-one function, and when the domain and range is specified, and then when x1 and x2 belongs to your domain A, then you can say that if a function's value are same and also their points are same, if it's given two same values or either of them are not same or either of the functions value are not same, then it's one-to-one. In simpleton, we have to make sure that for one input there is only one value as output. Next, we will go through exponential functions. Graphs will be coming forward. First, what is the exponential function? It's a function which is in the standard form of ax, where x is raised to some powers. Let's say in this case it's raised to 1, but it also can be raised to 5, 6, 7 or anything. Here you should keep in mind that your coefficient of x should not be equal to 0 or negative. The reason is simple, because if you take negative values, it will direct towards negative infinity. And as we know that we are going to factors which are exponentially growing. That's why we tend to keep our output as positive. And if the coefficient is 0, then the x raised to exponential term will not matter because it will make the entire equation equals to 0. Also, your a is normally not equal to 1 in this case, same as the log functions, which we will cover in next week. The next thing is that, let's say there are some laws of exponents which you all should know. Let's say S and T are two exponential groups, means raised to powers, which belong to some relation and says that two elements A and B which are greater than 0. So now as you can observe that A raised to power S and A raised to power T, when the base, these A are called bases. When these bases are same and the operation between is multiplication, then the exponents get added. This is covered in 8th class 2, I'm not wrong. Then when a base is having a power which is again raised to some power, then the exponents are to be multiplied. And when you can say a base is there to some power, then you can split the base in multiplication and the power gets splitted. And let's say if here division was to there, as divided by 80, then here as minus t would have come. It's the same, that's why I have not come. Then secondly, here if a plus b to the power 8 is written, or a plus b to the power s, then you cannot separate it as a to the power s plus b to the power s. Next, we are going to see how to graph exponential function. Here, as you can observe that 2 is our base and x is our exponential factor. So 2 to the power x is a increasing function, as you can see. The graph starts from here and just goes on increasing. That's why it's an increasing function. At every point, the previous value at that previous point is always less than the next point when you are moving through the exponential functions or the increasing or increasing functions. In this case, our function is 2x as specified. The domain of the function is R and the range of the function is 0 to infinity. Anything to the power 0 is always 1. That's what you should always keep in your mind. And as we know that we have here, it's an increasing function. We are starting our base value, which is a, which is greater than 0. As you can see here, 2 is kept in the base form, so it's fulfilled. And second thing is that when you will substitute any value in the form in 2's place, the minimum value that you can get after substituting any value in x is 0. That's why it starts from 0 and it goes till infinity. As you can see, this is the y-intercept here, 0, 1. Second, x-intercept. The line actually never cuts. Here you can observe that the line appears to be cut, but in actual sense, the line is never touched to x-axis in either side. This is a fact to be keep in mind. Then the end behavior, as x tends to infinity, to the power x also tends to infinity. And if x tends to minus infinity, then 2 to the power x tends to 0. As I have previously mentioned, the minimum value that 2 to the power x can attain is 0 itself. Also, there is no root of the function because it never intercepts x-axis, and roots or zeros are the number of terms which are present when the graph cuts x-axis. Also, this function is the increasing function. This is the graph of exponential function. It's same, only difference is here. Instead of 2x, we have taken 3x just for more clarity. Domain is R. Range of many exponential function when raised from some base to x is always 0 to infinity, which you can keep in mind. The intercept stays the same. All the exponential function will never intercept x-axis. As x tends to infinity, ax tends to 0. This is the general equation ax of exponential functions. Then when x tends to minus infinity, ax tends to 0. Minimum value. This is the function ax. We have taken an example of 3x to show this graph. This is an increasing function. Let's take a look at the decreasing function. This is same. The only thing is that, as you can observe here, the number taken here is between 0 to 1. As you can see that exponential function base can contain 0 and 1. Therefore, any number between 0 and 1 is always shows a decreasing exponential functions. As you can observe from here. Domain is R, range is 0 to infinity, same, y-intercept stays the same, 0, 1. X-axis is never interpreted. Then as x tends to infinity, your ax tends to 0. The reason is because this is a decreasing function. Any base with raised to x as exponent will be decreasing function if its base is between 0 to 1. And as you can see here, when x goes to minus infinity, the ax term goes to infinity. No roots as usual. This function is a decreasing function. The reason is because the base is between 0 and 1. And if the base was greater than 1, then it's a increasing function. As this is the graph of the function. Moving forward, these are the natural exponential functions, which are written as e to the power x, where e is always greater than 1. Here e can be used as variable. Also, there is a constant e, which is approximate value as 2.17 something. Then there is domain, which is real numbers again. Range is 0 to infinity as usual. Then this function represents an increasing function by default. But if you will take 1 by e to the power x, then it will become a decreasing function, showing a graph of something like this. Showing a graph of something like this. You can easily observe the area under the ex function is minus infinity to 0 because it starts from minus infinity and goes all the way around infinity. Same goes for the natural exponential function. There are no zeros or roots of this function because it never intercepts the x-axis. Now, we will be going through two new terms. One is the composite function and second is the inverse function. What are composite function? Let's say you have given two functions for now. First is fx, which is written as 3x minus 4. Second, you have a gx written as x squared. So composite functions are functions when you have substituting one function in the place of another function as variable and then solving for it. Now, let's say you have asked f of g, which means that you have to substitute the gx function in the fx function and then calculate the domain or range as specified by the question. Let's say in this case, f of gx is nothing but substituting gx in the place of x in fx. Here you can see in the function fx, we are substituting x square, which is the function gx. Then after putting x square in the place of fx, you will get 3 times x square minus 4. This is the composite function. Also, it can go either way. It can be f of gx or g of fx. If it was g of fx, then in place of x square, you need to... If it was g of x square, then you might have substituted 3x minus 4 in the x square term. This is your g of fx. 3x minus 4 raised to whole square. In this case, when asked for domain, we have to calculate a domain of g of fx. Also, we have to keep in mind there are two specific rules that are used while finding the domain of the composite functions. Let's say you have got a composition function f of gx in which your x doesn't belong to the domain of gx. In that case, you can simply write that your x does not belong to the domain of f of gx. If the internal domain is not satisfied, if the x doesn't satisfy the internal function domain, then it's not the part of the domain of the composite function. Then in the second rule is that, let's say you have a gx which does not belong to your domain of function, means the output of your gx is something. Let's say your output is 4 by 3. In this case, you know that after substituting 4 by 3 as your gx, your fx becomes 0. That's why that will not be included in your domain of composite function. That are the only two rules you have to keep in mind. We will go through the examples in upcoming video. Then next is the inverse function. Inverse functions are just remapping of a range to domain by changing their perspectives as domain to range. Let's see, you have a function of domain D, and then let's see you have domain function, and then this is a range. This is how a function goes. Now you will make this a domain and make this a range. In this case, you can observe that it's reverse. That's why we call this is inverse function. That's why we call this as reverse function, inverse function. Also, only the functions which are one-to-one can be inversed. Because when you will substitute a function's inverse in the function itself, then it's equals to the inverse function substituted in the inverse function, which gives the value of x. The best example is sine inverse of sine x is x, and also sine substituted in inverse sine x is also x. In this case, your domains of function and range of inverse function is same, whereas range of function and domain of inverse function is same. The very easy way to solve this question is just by changing your values of x and y in an equation to y and x. Let's say you have an equation of y equal to x square, and you are asked to find the range of the inverse. Then you will just write it as x equals to y square and just solve for y. As you know that y is equals to root x is your solution. Okay guys, so let's begin with the questions part. The first question is here. So here we are given a mod function, and if you know, a mod function is a function in which any input you give, positive or negative, gives its positive version out. Let's say if you are given -2 as an input, it will give you 2 as output. Even if you give 2 as an input, it will still give you 2 as an output. So in this case, you can see that we have to check if this function passes horizontal line test or not. As you can clearly see that this mod x function doesn't pass horizontal line test, because as you can see the two inputs direct towards a single output. That's why this function is not a one-to-one function. Moving towards the next part. In this, we have to write this expression in a term of single based form. So moving downwards, as you know that 4 raised to 5, which is raised to 3, as you know that when 2 raised to's are there to a single term, then both the raised to gets multiplied, giving 3 into 5 as 15. Same goes to 4 can be represented as 2 square. So again, 2 raised to 2, which is raised to 15, which will become 2 into 15, giving the base as 2 base, whereas exponent is 30. And when base are same and there are 2 exponents, then we will just add them, making your answer 2 is to 33. This is a simple question. Moving forward, this is a nice question. In this question, what we are doing, let's see. First, we have told that we have RT, which is the equation where variable is t, which is 50 minus 100 times e raised to minus 0.2 times t. In this case, t is a variable which represents time. And this function gives us percentage of people who respond to affiliate links under YouTube descriptions and purchase the product in time t. So in this case, let's say you have a YouTube channel and then you have put some link in description and then people will click it. And then if let's say this equation will tell you by how many percentage out of, you can see here 50 is the total percentage that we can get. So out of 50 percentage, how many of them have purchased it in the given time is what this equation can tell. So our first question itself is that what is the percentage of people responding after 10 minutes? So in this case, directly you will substitute the value of 10 in the equation. And after simplifying, you will just get 50 minus 100 times e to the power minus 2. You can substitute the value of e as 2.17 and then calculate it, which will give you answer of 36.46. You can use calci for this measure. And this is your answer for the question A. These are easy questions. You just have to substitute the given values in the equations. The second question is that what's the highest percentage expected? In this case, you can directly observe that when your equation here can attain a maximum value of 50 only. That too when your second part minus 100 e minus 20 point minus 0.2t becomes 0. At this point, your maximum value of this equation becomes 50. Therefore, you can directly conclude that the highest percentage expected is 50. But in the same way, you can calculate that when your exponential part, this part becomes 0, even 100 becomes 0. Just to hear this. Yeah. When your e to the power minus 0.2 times t becomes 0, the minus 100 factors gets cancelled, and this making your answer as 50. Also, you can see that if this negative sign could become positive, then also your expected highest value would increase. But as you know, the exponential functions only give one value. Either they goes on increasing or decreasing. In this case, your function is going on increasing. That's why your value will never be more negative, this minus 100 part. That's the reason why this part will always remain subtracted and the minimum value that can be subtracted is 0. That's the reason why the 50 will be your maximum value that can be attained. And then the last part is that we have to find how much time is taken before our function exceeds the 30% rule. Let's say in this, you can directly substitute the values which is equals to the function because it's given. So after simplifying, you will come down to this step. In this, you just have to do some simple manipulations like 50 will go minus 100 times e to the power minus 0.2 t will go to other side, and then 50 minus 30 will give 20, and then simplify, and then you will get this equation. After getting this equation, you just have to apply log. Now, you may not be familiar with log till now. I assume that. So simply, I will tell you what you have to do. In this case, e will be going towards this side, making this something of ln of phi raised to minus 1, which you can write, which is equals to minus 0.2t. In this, you can observe that this minus 1 will come here. The reason for me to take ln is because we have taken e as our base and e coincides to natural logarithms, which is written as ln. So after this, you can see this minus and this minus will get cancelled after it has came forward. So we'll get ln phi upon 2 into 10, which is equals to t. Here 0.2 is, you can write is at 2 by 10, which will become 10 by 2 here. So the value of log phi is something approximately 1.6 if I'm not wrong. Then we will multiply it by 10 and then divide it by 2, which you, after solving, gives you an average something of 8. And as you can see, your final answer that you will get time which you have to calculate is that by how much time it will take to reach exceed 30% is also 8, which means that after 8 minutes, your graph will cross 30%. So that's solved in this question. You can practice this question again. These types of question may come in your quiz too. Next question. Let's see. A shopper is offering 2 discounts on products of MRP 14,000. Okay, the first discount is of 15% on MRP. And second discount is flat 3,000. Okay. If both discounts are applied, what is the final cost? So let's say first discount 15% off is applied on your 14,000 mark, and then your 3,000 flat discount will get applied. Now we know that let X be the price as usual. After that, applying 15% of discount will give you something of function of your first function as fx is 0.85x. If you don't understood, then you have to take 100% is your price, which is 1. Then you will minus 15% means 0.15 is subtracted from 1, giving you 0.85 as your main function. This is the function which is you will get after applying first. Then you have second discounted price, which is flat 3000, means subtract 3000 from your total amount. That's why your second function is the gx, which tells you that your amount minus 3000 is what you will be getting. Also, if you will think, if you try to go, you have two methods. Either you can do POG, which is first take this discount and then apply this account. But then you are the second, when you will apply this first, the 15% discount will be applied on the amount which is got to you after you have got gx amount. And then the gx amount will be applied when your fx is already been calculated. So we have to put fx in gx, because 15% is applied on the MRP itself. So first it will be applied. That's the reason why fx will go into gx, which means g of fx we have to find out in this case. To identify that which function has to go in, you can directly see whichever is directly applied towards the main x that you have, that will be going as the inner function. Here you can see 15% discount is applied on directly MRP, and we have to find what is the MRP only. And our main calculations are beside MRP. That's why this function will go inside the gx one. That's how we find out. Then we know that according to hx, that is g of fx, x minus 3000, which is your x's first step one. Then you will substitute x value, which you will get 0.85x minus 3000. Also, you have given that your MRP is 14,000. Now you just have to substitute 14,000. You will put here and then keep substituting. 0.85 into 14,000 gives you 11.9k minus 3k, which will lead you to 8,900. So your final cost after applying both the discounts is 8,900. That's all. These questions are pretty easy if you just understand that how you have to apply the composite functions. Moving to the next question. Let's say you have given a fx function 2 upon x minus 1 and gx function, which is 3 upon x. You have to find the composite function of f of gx and then domain of the f of gx. In this way, simply you have to substitute the gx function in the place of x. You can write, you can skip this step and directly write that 2 upon 3x minus 1, which after simplifying will become 2x upon 3 minus x. Then you have to find the domain. Domain means that real minus all the parts that will not be part of your function. And if you know that when we have to find domain, I have specified two rules in the beginning of the lecture. One is that anything that doesn't satisfy your gx will not be part of your domain of your f of gx. Means if something doesn't satisfy your inner function, then it will not be part of the composite function either. That's why here you can see if you will substitute x as 0, it will become 3 upon 0, which will become undefined. And when you will substitute undefined in this x position, undefined minus 1, and then it's divided, it has to divide 2, which is not possible. That's why this composite function will become undefined at 0. Even if here you will see that 0 is possible, but still 0 won't be a part of here, because your actual function is 2 upon 3x minus 1. That's why. This is a rearrangement form. That's why 0 is something that won't be part of your equation. Second thing, directly you can observe here that when you substitute here 3, your functions become composite function because undefined. That's why 3 is the second factor. So whenever you have to find domain, you have to just find the factors that doesn't satisfy your composite function and the inner function separately. That's the only two things that you have to see. That's why your domain of the function is real numbers, subtract the set of 0 and 3. Okay, now this question. In this you will have given fx, which is 3x minus 4, and you have a gx of x squared. In this you have to find g of fx, also f of gx. Okay, so now let's see. First, you will do that. We'll substitute. First, we have to find g of fx. So we'll substitute fx in the gx. So 3x minus 4 will substitute in the x square. When you will open it, you will get 9x square minus 24x plus 16, which is your first g of fx. Then you have to find f of gx. As you can see, you will substitute x square in this. You will directly get 3x square minus 4. You can skip these steps because this is another theoretical paper. So you can skip these steps and you will get your answer x. 3x square minus 4. These are very pretty simple questions, and these do come in your qualifiers, means quiz 2 rounds. Moving forward to next question. Okay. In this question, we have given a gx and hx, and we have to check if g is the inverse function. There is a very easy method to check if g and f, any two given functions, are inverse or not. You just have to calculate g of hx and h of gx. If both of them are same, then the function is inverse functions. The reason is because when, as we have previously seen, if you will apply f inverse in f, then it will become only x. Whereas substituted by f inverse will also become x. That's the reason why. Here theory has been given. If you want to recall, we'll just go to the solving part. When you will substitute x upon 4 in 4x, you will see that your remainder will be only x. Now checking for the same, substitute 4x in the x upon 4. Here also you see you get the value of x. This gives us the data that the function g is the inverse of h and vice versa. This is a pretty easy question. Let's see our second last question of the day. Here we have given gx, which is x cube. Then we have given g inverse of which is x raised to 1 upon 3. Okay. Then we have told that g inverse of gx is equals to g of g inverse x, which gives x. Means these functions are reversible. Next thing, we have to verify that g inverse of gx is equals to x. So in this way, you can simply keep substituting and the same. Let's say you can just keep, if you don't want confusion, you can keep gx as hx. And you can keep g inverse of x as fx. And then you can solve for both f of gx and f of hx and h of fx. It's the same as the previous question we did. Probably you will get same answer x and x. That's why you can justify that this is true after all. Going forward to the last question. This question we have got fx as x minus 5 upon 2x plus 3, and the which is inverse of a function gx, which is 3x plus 5 upon 1 minus 2x. Okay, so we have to check if it is or not. So simple, you will calculate f of gx and then g of fx. Substitute the value of gx in fx. Substituting, then simplifying this. Only the calculations part can be tricky, which you have to practice. Remaining all will be cancelled if the answer is to be correct. Then you will just get that f of gx is x, which means that this is reversible from f of g perspective. Then if we will check for g of f perspective, the same, will just substitute the fx function in the value of x where in gx. Then the same term you have to just simplify here, basic calculations. After that, at the end, if you get the same answer as the f of gx, then and g of fx is also same, then you can say that this both is true. F of gx is equals to f substituted, which is by gx, which is equals to x, which is again g substituted by fx, which is g of fx. That's why you can say that fx is inverse of gx. That's all, guys. Don't forget to like, share, and subscribe. And also, I would recommend that from now on, we should take our studies more seriously, because term 2 and final term may get a little bit tricky, because in the upcoming weeks, after the functions part, some basic trigonometry and also calculus part is going to come. So that's all. Thank you.